So hopefully this topic isn't too new for people. This is one of the things they do hammer quite a bit in middle school and high school. So let's go ahead and start off with examples and just kind of review everything as we get going. Easy example to start with, x squared plus 5x plus 4 equals 0. So we've got quadratics now. We're setting it equal to 0. This is equivalent to finding the roots or the x-intercepts of a quadratic function of a degree 2 polynomial. And notice that we start with it in standard form. In this case, we've got ax squared plus bx plus c. Our a equals 1. This is the easiest case. So we're going to start with our easiest case, and then also notice that b is positive and c is also positive. So b is 5, c is positive 4. So when c is positive, we are looking for factors of c. That add to b. So our c is equal to 4, and we factor that either 1 times 4 or 2 times 2, and we need to choose the factors that add together to get 5. In this case, of course, 1 and 4. So the way this quadratic polynomial will factor is going to be x plus 1 times the quantity x plus 4. And so our 1 and 4 just go in the sort of opposite side of our factors. And we're going to take advantage of the mathematical fact that if we have two expressions, a times b, that equals 0, then a equals 0 or b equals 0, or both. So when I have a product of two things, two expressions equal to 0, we can set each one equal to 0, and we will get -1 and -4. As our solution to this problem. Usually helpful, of course, once you get to the end of the problem, box your answers, especially for written homework, so it'll help all you understand what to grade and what to look. Next example, let's get a little bit harder, or I guess different, I don't know, depends on what you find hardest and whatnot. Our leading coefficient is still going to be 1. So still fairly easy, but notice that c is negative. So in this case, we want factors of c whose difference is b. And I will say, of course, sum if you consider one positive and one negative. So it kind of depends on how you look at it, of course, to match the words of whether we're adding or whether we're taking the difference of the factors. Primarily, like if we just consider c, well, it's -10, but if we're really just looking at factors of 10, we've got 10 and 1 and 2 and 5. So if we're just considering positive factors, I'm looking for the difference to get -3. So in this case, we're going to want 2 minus 5. And we're going to factor our quadratic then. I want the 5 negative, so I'm going to have a +2 and a -5. That's that, factoring. And then, of course, we'll get x plus 2 equals 0, x minus 5 equals 0, and x equals 5, x equals 2, negative. The only other way, like if you want to consider it as C as negative, like if we had negative 10 here, of course you could factor it as like negative 10, positive 1. You do just have to potentially toss around the negative between the factors. 2 and negative 5, of course, negative 2 and positive 5 could have worked out. And now if I'm keeping track of the negative, now we're just looking to add the factors. So if we chose this one, of course, we'll get negative 2 plus 5 is a positive 3. Not what we want. And so we would want, of course, this guy. 2 plus a negative 5 gives me the negative 3. And so our positive 2 and our negative 5 are those factors. All right, let's get a little bit harder now. So that C term determines whether we're looking for a sum or a difference. The sign of B then kind of, if you're taking a sum, the sign of B determines whether they're both positive or both negative. So general rules people are taught, if C is positive, then it's always going to be either plus plus or negative negative. And whether it's plus plus then determines, or negative negative is determined by the sign of B. So since B was positive, we want plus plus. If this B were a negative 5, sorry, let me get that on screen. If the B was a negative 5, but this were still positive, it would have been negative negative there. When C is negative, one is always positive, the other one's always negative. You just have to determine which one based on the size and sign of B. So since B was negative, you want the bigger one to be negative, essentially. If B were positive, 3, we could just flip those two and we would take the smaller factor as negative. If we have an example where A is not 1, in this case, at least our A is positive. So let's make a note. If A is negative, multiply everything by negative 1. It'll just make factoring easier. It'll help you prevent from making negative sign errors down the road in the factoring. If your A term is negative, factoring, it's like an extra weird thing to think about when factoring. So it's easiest, especially when we're setting something equal to 0. If this term is negative, multiply everything by a negative 1. It won't change the solutions. But A is positive, and then our C, once A is positive, is also positive. So again, we want factors of 4, or at least we're going to add our factors, but we have to count for the factors of 9. So we are actually going to look for the factors of A and C, whose linear combination is B. And what do I mean by that? This linear combination, we're going to have 9. So our factors of 9 are 1 and 9, 3 and 3. And factors of 4, 1 and 4, 2 and 2. And we're looking to get 15. So we're going to start off with one factor of 9, multiply it by a factor of 4. So I can start off with 1 times 1. Then I'm going to take the other two factors, multiply them together, 9 times 4, and then I'm going to add those two products together. So that gives me 1 plus 36, 37, not going to work. You have to be careful using this method because you can just change the order. So I multiplied 1 times 1. I can choose those same factors, but in a different combination. So I can do 1 times 4 plus 9 times 1. So 1 times 4 now, 9 times 1. Add those two products together. What do we get? 4 plus 9 is 13. Close, but doesn't work. This method can be a little bit tedious if you're not used to seeing it immediately and kind of running through some of these guesses in your head. So we'll try another method after this, and I'll show you the factoring by grouping. Just to finish this one off, let's take a look. So now we want to choose a different combination. Let's choose the 3, 3 and the 1, 4. So we'll have 3 times 1 plus 3 times 4, which gives me 3 plus 12, gives me 15. And so now that we have our 15, you just have to set up your parentheses, your two factors. It's a 3 and a 3, so that means the factors of 9 are going to be the coefficients in front of your x's, 3x and 3x. We've got a 1 and 4, and both are positive. So we have a +1 and a +4 there. Be careful when these two, so it depends on how you're multiplying as to which factor the 1 and 4 go in. The reason it doesn't in this case is because both of the 3x's are the same. If these were different, you would want to make sure that like this factor, if I had like this 3 times this 1, then it would be this 3 times, I would need a 1 over here. But since they're the same, I could say, well, this 3 times this 1 gives me that 3 times that 1. This 3 times that 4 gives me this 3 times that 4. And those will combine to get this 15. So check that, FOIL that out on your own, and check that the linear term, the b term, does add to 15, and of course all the other terms match what we would have gotten. Solving this, we'll get 3x equals -1, 3x plus 4 equals 0, so 3x equals -4, and x equals -1/3, x equals -4/3. The method was a little tedious. Let's do a factor by grouping method. I've had back and forth results from students, or just interest as to which method students prefer. Some students really like this method and are just used to doing it. Other students are taught factor by grouping and think it's a little bit better. Okay, so let's let me try to make one up here real quick. Let's say 5x squared. And let's see, a plus, I don't want to use 4, I want different factors. Let's say +6. Actually here, let's make it negative. So let's say -6. And so we've got, let's say +13. And equals 0. So similar situation, our a term is 1, or not 1, but bigger than 0. And so we could redo the method we just did, but can be a little tedious doing all the guessing and checking. What we're going to do instead now, so let's write down our c is less than 0. So linear combination of a and c to get b. This step, I mean, you can almost ignore that statement as how we're going to solve this, because if it factors, and if it factors by grouping, what we can actually do is take a times c. In this case, is going to be 5 times -6. Gives us -30. And then look for factors of a times c that add to b. And I'll just say, be careful of whether we're adding and subtracting. I'm saying add because we're keeping track of the minus sign. So since I'm keeping track of the minus sign in the factors, we are going to be adding, but one will be like adding a negative. So depending on how you factor it and how you phrase it, you could think about subtracting them or taking a difference of factors of 30 to get 13. So we can factor our 30, and let's keep track of the negative. We've got 1 and 30, 2 and 15. And of course, 1 and 30, no matter where we put the minus sign, how we add and subtract isn't going to work. 2 and 15, though, when I take the difference, what do we get? We get 13. And which one needs to be positive? The 15. So negative 2 plus 15 gives me 13. And we can stop there. Of course, there's 5 and 6 other factors, but once we find the correct factors, we're good. Okay, so here's how this works. We've got 5x squared plus 13x minus 6 equals 0. And we know our factors of 30, negative 30, that we want are negative 2 times 15. So what we're going to do in this next step, so I'm not leaving myself space for notes, I'll just kind of write it off to the side here. We are going to use those factors to essentially split the b term, the middle term. So our 5x squared is going to remain the same. Our 13x, so we're using the sum of these two to write that 13x. So 13x we can write as the sum of negative 2x plus 13x, or excuse me, 15. Can you guys read that? Let me just rewrite it. Perils of writing on paper. I don't have an eraser. I don't think pencil would show up well on the videos. So negative 2x plus 15x. And then we've got negative 6x, or excuse me, minus 6 equals 0. So that's how we're splitting. We're finding those factors that add to the b term specifically so we can split it. And a few notes, it doesn't matter what order we put those in. I could have write it as plus 15x minus 2x or vice versa. Shouldn't matter. And then what we're going to do is group the first two and second two terms. So this 5x and negative 2x we're going to group. The 15x and negative 6 we're going to group together. We're going to factor each groups. (5x) and 2x, we're going to look at the constants. So 5 is prime, 2 is prime, and they are co-prime together, so we can't factor anything out in terms of the constants. So the biggest factor I can factor out of this first grouping is just x. So I'm looking at the variables now, x squared and x. You can factor out 1 power of x and get 5x minus 2 left in that grouping. And we move on to the next grouping. It is a 15 and negative 6. What is the biggest factor we can pull out of both of those numbers? Should be 3. So we'll have a 3. And what do we have left? We'll have a 5x minus 2. And this should always work out. Notice that once you factor each of those groupings, what is left is the same thing. Should be exactly the same now in both groupings. And now we can factor out the common grouping. I'm going to do this in a couple of steps, so it's just extra steps if you guys want to follow it. They're not necessary if you can kind of see how to factor this. But it is a technique that we'll start to get into. We call a U substitution or a substitution method, because some students have a little bit of hard time kind of seeing this. What we can do is, let's just call this entire expression W. So W is 5x minus 2. And this, of course, 5x minus 2 is also W. If I'm just calling W equal to that expression, then really what we have is x times W plus 3 times W equals 0. And what we want to do is factor from this now, from these two terms. The largest factor each of them have in common is this W. So I can factor out the W, and what do we have left? X plus 3. And now back substituting, what was W? W was this grouping of 5x minus 2. And it's this line that we really want to get to, right? That is our factoring for that original polynomial. And now we just solve. So we get 2/5 and -3 as our solutions for this. A bit quicker with factoring by grouping. If you can understand how to do this step, how to factor out the grouping and how to split the B term, it's a little more foolproof. There's less guess and check involved, because once I take the product of A and C, we're only looking for those factors that add to B term. We don't have to check different combinations of different factors for both A and C. So choose whichever one you like, or if you have another method and want to run it by me or talk to me about it in office hours if you were taught a different way, feel free to check up with me. Happy to kind of confirm with you guys. Any questions on that? Cool. So that's about it for today.